A car is fast, but a snail is slow. Speed, we say, is how slow or fast an object moves. Now let's look at the meaning of rate. Rate means the change that occurs in one quantity when compared to a unit change in another. But speed is the rate that compares distance to time. It is the distance covered per unit time. Alright, now let's look at types of rate. We have uniform rate, which is also called the constant rate. We have the variable rate or the changing rate. We have average rate, and we also have speed. All right. Okay, now let's take an example on rate. We have two questions here. The first question says the area of a square increases by 20 centimeters squared when the side increases by 4 centimeters. What is the area? Rate per unit centimeter. Alright, now let's go to the board. We start with the increase in area, which is 20 centimeters squared. Using proportion, we can thus say 20 centimeters squared is equivalent to 4 centimeters. That is the length of the side of the square. 20 centimeters squared is equivalent to 4 centimeters. There is the length of the side that increases when 20 centimeters of its area is increased. Alright, let's allow the unknown increase per unit centimeter be y. So now representing the unknown using a letter. So let's say it's y centimeters. Increases when 1 centimeter of the side increase, or when the square increases by 1 centimeter. So y is also equivalent to 1 centimeter. Now using proportion, we'll try to find the value of y. Of course, we are going to have 20 centimeters squared, 20 centimeters squared multiplied by the 1 centimeter. 20 centimeters squared multiplied by the 1 centimeter all over 4 centimeter. All over 4 centimeter. So when we do this division, we are going to have 4 into 4, 1. 4 into 25. That will be equal to 5 centimeter squared. That will give us 5 centimeter squared. Alright, 5 centimeters squared we increase per centimeter of the side. So this is called the rate of increase of area per unit centimeter. Now let's quickly look at the second question. In this second question, we were told that a cab driver charges 200 naira for the first kilometer and charges 150 naira for subsequent kilometers. Note that there are two types of rates in this question. So the question is, how much did he charge for a distance of 6 kilometers? Alright, now let's go to the board. Well, the first thing we try to do is to establish the first rate. In the first rate, we are told that the cab driver charges 200 naira for first kilometer. 200 naira for first kilometer. Remember, first kilometer is 1 kilometer. And we have a total of 6 kilometers. That means if we remove the first 1 kilometer, we will be left with 5 kilometers. So we are going to therefore calculate the charge for these 5 kilometers. Now, if he charges 150 for the rest of the journey, it means the 5 kilometer will be multiplied by the charge per kilometer. And the charge per kilometer is 150 naira. So we have 150 naira times 5 kilometers. Of course, the result is 750 naira. 750 naira. Note that this 750 naira is the charge for the 5 kilometer. But we need to know the total charge for the 6 kilometers. And this simply means we have to add up the charge for the first kilometer and the charge for the 5 kilometers. Alright? So now, recall that the charge for the first kilometer is 200 naira. So when we add this 200 naira to the charge for the 5 kilometers, we will have 200 naira plus 750 naira. So when we add up the two values, we are going to get the sum of 950 naira if done correctly. 950 naira. So this is the total charge for the journey. Alright, let's take something on equivalent rate. First, equivalent rates are rates that are equal in values but might look different. This is as a result of changing the unit of one to the other. For example, kilometer per hour to meter per second. Now let's look at this example. To change 36 kilometer per hour to meter per second, we have to change the various units. For example, kilometer must be changed to meters to get 36,000 meters. And the time 1 hour must be changed to seconds. Note that the 1 hour is exactly 60 minutes and 60 minutes is 3,600 seconds. If we reduce to the lowest term, we will have 10 meter per second. So this is the speed. Alright, now let's look at another example, but this time on speed. Now we have two questions here. In the first example, we have a car moves at a speed of 36 km per hour for 10 minutes. What is the distance covered in meters? Alright, let's deal with this first problem. Now the first thing we are going to remember is this, that the units are different. Okay? And first of all, if we are to express our work in meters, of course, we are going to change the units. Alright? So, we will have 10 minutes expressed in hours. And that is 10 over 6 hour. So when we reduce, we'll have 1 over 6 hour. 1 over 6 hour. So we have the time expressed in hour because the speed given to us is kilometer per hour, not per minute. So the next step is to make use of the formula, the distance formula. That is, distance is equal to speed times time. Alright, so now let's make use of this formula. Recall that the speed is 36 km per hour. And now the time is 1 over 6r. Okay, so we have to multiply the speed and the time. So we have 6 into 6, 1, 6 into 36, 6. So what do we get from this? We get 6. So that is 6 kilometers. However, they want us to express our answer in meters. And to change this, we have to multiply by 1,000. So what do we get? Of course, 6,000 meters, because 6 times 1,000 is 6,000. All right. So we are going to take the second question, which is the last one. At what speed must it travel to complete the journey in 1 minute and 30 seconds? All right. The answer must be given in meter per second. Well, since our answer must be in meter per second, we must convert the minutes and seconds to seconds. The time given to us is 1 minute 30 seconds. So this is a combination of two units. So we must change to seconds. So 1 minute 30 seconds is 60 seconds plus 30 seconds. And that gives us 90 seconds. All right. Now that we have the time taken to find speed, distance. However, we know our distance is 6,000 meters. So speed formula is distance over time. And so that means we are going to have a distance of 6,000 meters. All right, 6,000 meters. So what do? We divide the 6,000 meters by 90 seconds, which is the time given. All right. So we try to reduce the zeros by simply deleting the zeros below and on top. So we are now left with 600 meters, all right, over 9. So when we divide 9 by 3, we get a 3. When we divide 600 by 3, we get 200. So we are going to have 200 meters, all right, 200 meters divided by 3 seconds. All right. Now, if we carefully do this, 3 into 20 is 6, remainder 2, into another 20 is 6, remainder 2. So when we put 2 over 3, we have 66 whole number, 2 over 3 meter per second. So this is the speed. Alright, hope you had fun watching and learning in today's class. Thanks for watching and see you in the next class.